Greetings everybody and welcome. Today we are going to discuss and create our own factory object, which will be responsible for creating new objects as a factory would and maintaining their lifetime. So once the factory goes out of scope, anything that it has created will be destroyed for us. So we don't have to worry about memory leaks. So there's no fancy slides or other presentations for this. I do highly recommend going to see my typer video, or my type tokenizer as I call it, and also my capabilities video, because there are two types in there that we will be using again, including the type ID and our deletables. So those will be very, very important. Otherwise, though, we're going to go ahead and jump into this. I am going to do something a little bit different. Rather than starting to build the factory, we're going to start using the factory just to illustrate how this thing is going to work. Obviously, we won't be able to compile it, but we'll essentially write the way we want to use it, and then we'll fill in the implementation a little bit later. So, all right, what's our factory going to look like? Well, effectively, we want to be able to create a factory object like so. And we want to be able to do something like, let's not do person, let's do customer reference of customer equals, and we will do factory of customer. And we'll name it Bob, we'll say. All right, so what this will effectively be doing is our factory will go, hey, I'm sorry, this is supposed to be .create. Off to a great start. There we go. All right, so what this will basically be saying is, hey, factory, I want you to create a customer, and I want you to pass the string Bob as its first argument. And it will go ahead and do that. It will maintain the lifetime of its new customer that it creates, and it will return a reference to that customer back to us so that we can then go ahead and manipulate it. So we'll be able to do things like customer.sayHi, or whatever a customer would do. So the first thing we'll do right now, I guess, is fill out our customer, so at least that's working, and we won't have to come back to this. And we'll give it a std string of name, and we'll also give it a constructor, which takes a const std string, also called name, and in the initializer list, we will assign the name out. So, all right, that should work. Yeah, I think everything's good here. This, again, we don't have a factory yet, so we're still going to get some errors. So that's all our prep work. Let's go ahead and start creating our factory. Oops, wrong one. Include add new item, and we're going to call this factory.h. Now I'm going to go back here real quick to our main, and I'm going to go ahead and include factory just so I don't forget to do so. All right, so we need to start including some very useful headers. We're going to be using std move, and that can be found in utility. So we'll want that. We're also going to need vector for storing all of our object instances, and we're going to need unordered map. And that is going to allow us to link objects to types. And we're also then going to need our typer.h so that we can get the type information, essentially a type token identifying the types we're going to be using. And we're going to be using our deletable capability, which will allow the factory to automate the destruction of resources. So that's essentially all we're going to need to cobble this thing together. We are going to need some sort of meta container to store information about our object, including the deletable capability so that it knows how to delete itself. And we also need a pointer to the object we are going to be manipulating, or owning, I guess. So we're going to create something called factory data. Now, I suppose you could use like a tuple or whatever, but I really like having my fields explicitly named out so I can see what's what. So we're going to go ahead and create a struct for this. And the easy one here is going to be, or the non-scary one, I will say, is going to be our deletable, and it's a deleter. And now, for all of you who might be a little questioning my ability to program, you might be questioning it further as I type this line of code. This will be our pointer to the object that our factory will be owning. And yes, it's a void star pointer. If you've taken a level 1 course in C++, you're probably very angry right now. Don't worry about that though, because we will make it to where this void star pointer is never accessed directly outside the API. And when it's accessed inside the API, we will guarantee that the type we are casting it to is always the type that we expect it to be. So we'll get into that a little bit later, but just know we're going to make this as safe as we possibly can and not leak it out so that somebody could misuse it by accident or maliciously, I suppose. All right, so that's... Oops, no, we aren't quite done with this. We're close to being done with this. The other thing that we're going to need before we get into our factory is we want to, of course, be able to assign an object to our factory data. And we're going to do that using a templated constructor, which I love. And the reason we need a templated constructor as opposed to sending a void star, which again, that's kind of frowned upon, is we actually do need the type information. We need the type information so that the deleter will know how to delete the object. And we're going to also go ahead and assign the object reference as well. The other thing that factory data is going to need is a move constructor, because we will have our factory data inside of a vector, and the vector is going to need some way of moving its contents here and there for when I insert things or remove things and stuff like that. It'll need some way of interacting with the objects, and so we're not going to allow it to do copy construction because we might accidentally duplicate our deleter. In fact, our deleter does not even support copy construction, so the only alternative we have is move constructors, and that really makes the most sense in this context. So we're going to go ahead and we're going to move our deleter from the right-hand side argument, which is the guy we're stealing the guts from, and we're going to move it into our current object. And there we go. So that is all that we need for factory data. So let's go ahead and create our factory class. We'll have a public section, but before we get to that, we're going to have our private section. And our private section is going to hold our container, which will manage and allow us to effectively organize our resources. So how we're going to do that is with an unordered map of type ID, because we want to categorize our resources by their types. So, you know, I can get just customers or just invoices or whatever. And for each type, we're going to have a list of those particular resources. So this is where we have our vector of factory data or data, and we're going to call that objects. So as you can see right here, remember this void star, still a touchy subject, but as you can see, we're going to be accessing it from within a list that has information about the type. And so that's how we can guarantee that we will always be accessing exactly the type that we want and nothing else. For instance, well, we'll play with it. You'll see more, I guess, as we keep on going here. Let's go ahead and create our create function inside our factory. Please note also that our factory doesn't even need a constructor defined. It's that simple. For now anyway, we could actually make this to where we could move our factory, and that would be a really cool feature, but we're not going to do that right now. Alright, so I'll go into what I'm typing real quickly in case some of you are not familiar with variadic template arguments. So what we're going to go ahead and do with our create is, again, we need templates because we need to know exactly what type of object we're creating. If we go back to main here, well, actually here. So this object, this type object, is this customer in this particular case. So it needs to know that. From there on out, though, we have our type named ellipsis or ... args. And these will be the arguments that we will be passing to the constructor of whatever object this is when we instantiate one. And how we do this is through perfect forwarding. And essentially when you create a function, a member function, actually I guess any function in general, and you give it a variadic template argument list, and then you specify that you want it to be args ampersand ampersand followed by the ellipse, that notifies the compiler that you are attempting to forward the arguments on. And so to do that, to perfectly forward them in their entirety, we are simply going to create our object. So it'll be new object, and you call stood forward, pass in the args as a template argument, pass in the args object, or the args type as a template argument, and the args variable or parameter as its parameter. And then you add the ellipse at the end, and we have successfully constructed and perfectly forwarded our arguments, or constructed our object and perfectly forwarded our arguments, something like that. Okay, so now we've got our object, but it's completely unmanaged. So let's go ahead and manage that. So to do that, we need to open up our objects, which is our unordered map, and we want to access that type as our key here. So we're going to get the type of object and use that token as our identifier. And then we're simply going to place back our item, like so. And finally, we want to return our item. So it's as simple as that. So at this point, this code should theoretically compile, although it looks like, oh, because I done messed up, that's why. Should be .create. That's what I meant to do. I've had that wrong the entire time. All right, oh yeah, we forgot our say hi as well. So let's go ahead and build our say hi. And that's going to be stood cout name says hi. Is that semicolon? My keyboard has ways. Okay, there we go. Now this should compile. And it does. All right, so if we run this, we have Bob says hi. But now the question is, I mean, that's well and fine. I mean, it's actually pretty awesome if you think about it. We just did all that crazy awesome stuff, constructed a Bob and sent it back in. I mean, there's no new Bob or no new customer or no new anything. We aren't creating a customer like this and assigning it, you know, Bob. None of that's happening. Everything is happening from within our factory. And our factory manages that resource, but we can't see that yet. So if we create our destructor here, we can then do stood cout name was destroyed. There we go. All right, now once we run this, you'll see that Bob was destroyed. So that's pretty cool. Let's create a customer 2. We'll call this one Frank. And now you'll see that Bob was destroyed and Frank was destroyed. So this is kind of the cool part, because remember, we're keeping our object as a void star, yet somehow it's able to figure out exactly what type to call the destructor for. It's successfully grabbing Bob's destructor, knowing everything about it, and calling the customer destructor. And how it does that is because it's not using the void star at all. In fact, it's using the deletable. The deletable has the type information. It has a function that knows the type of the object that it's destroying, which was passed in through the templated constructor over here. Because, and if that doesn't seem terribly awesome to you, let me show you why that's awesome. If we were to do a horrible, horrible thing and type void star O equals new customer, and we'll call this Sue, and then we call delete O, and compile, and run, you'll notice at no point does it say Sue was destroyed. That's because this is undefined behavior. The memory itself was probably cleaned up by the compiler, but since void star is an unknown type, the compiler has absolutely no idea what destructor to call. So the type destructor never gets called, and that could cause potential memory leaks. With our factory system, though, it keeps track of the types that it creates, even though it's using a heterogeneous container. And because of that, it knows to create or to call Bob's delete. So let's say again we create an invoice or something along those lines, and we do. Let's see if I can speed this up a bit. we do invoice was destroyed. Then if I do invoice and invoice equals factory.create invoice. Remember, the invoice doesn't take any arguments for its constructor, so we don't pass anything. And we build. You'll see that it was successfully able to destroy the invoice, which means it was calling the invoice destructor. So yes, this is one of the awesome and useful things about the factory is once it goes out of scope, it not only releases all of its resources, but it also knows the type information for them and can safely release all of its resources. And of course, the beauty of the factory, in addition, is that you can tie this to any scope you want. And here we're just putting it inside of the int main, but you can always throw this thing inside of a class. You know, if you have something that processes invoice orders or something like that, and you need to spin up some objects really quickly, but you don't want to have to remember, oh yeah, I got to delete this or do that or whatever, you can actually put a factory as a field inside of an invoice processor. And when the invoice processor goes out of scope, the factory will go out of scope, and thus the factory will safely release all of its resources. And as such, you do not see any memory leaks. So this factory system is absolutely very useful. Absolutely love this thing. Can't even wait to get this working correct. I actually have a version of it in my game engine right now, but the one I'm showing you is actually a better one. The other one I made was its predecessor, and it's got a lot of kludgy code, we'll say, in the way I was trying to manage the resources. This one line saves kittens, trust me. I mean, this has cleaned up so much. So this is definitely the way to do it. So effectively, we're done at this point, but I do want to add two more functions to this. First off, what if you want to destroy a resource that you've created inside the factory, but you want to do it before the factory goes out of scope? So one of the things we're going to end up doing is creating our template type name object, and we're going to have a destroy method. And all we're going to do is just take a reference to the object that we want destroyed, and we're going to go through and what we're actually going to do is we're going to generate a brand new list that will be the same objects as previous minus whatever object we pass, which, by the way, I should probably give a name. We'll call it object. So it'll be everything. It'll replace the current list with a list that has everything except this object. So that's why the code is about to look like what it's about to look like. And I'll try to explain a little bit here and there as we go. So first we need the ID of the object, and we're going to grab that, then we're going to create a list. This will be our new list. This will be a if I can type, vector of factory data. And we're going to do for auto and data in objects of ID. We're going to go if the data.object is different than the pointer or the address of this object, or the object we've passed, then and only then do we want to move the data into the new list. All right. And then we do objects ID dot equals std move. Basically, we're going to move the new list into the old list. That's what's happening here. So effectively, that is the destroy method, and that will allow us to do cool things like, well, let's go ahead and build this and run it. Make sure we didn't introduce any new issues. So far, so good. So let's say we want to destroy Frank and then let Bob destroy itself. So let's go ahead and do that. We'll even do it down here just to show that it's actually working. So what we'll do is we'll do factory.destroy, and Frank is customer 2, so we'll go ahead and do that. And assuming all goes well, there we go. Yes, as you can see, we still have Bob says hi because that's up here somewhere, but then Frank gets destroyed because we explicitly destroyed him here. Whoops. And then Bob gets destroyed when the factory gets destroyed, and so too does the invoice. So it looks like our destroy pattern is working very nicely. And finally, the last thing that we want to do is, wouldn't it be really cool if we could run a callback over every type in the list? So let's say I want to do something with all the customers. Wouldn't it be cool if I could just say, hey, for each of these guys, call this function and pass the customer's first parameter? Well, let's go ahead and do that. Turns out that's pretty easy to do. And hey, we're at 43 lines of code, so we're still under our 50 line of code limit that I imposed in the last video. So let's see what we can do here. So we want to do template type name, and we want to specify what object type that we want to run this callback on. And then we also want to specify the callback. And now again, we're using C++'s cool type system here. So this callback can be anything. It can be a function, it could be a lambda, it could be a functor. You can do a std bind and bind it to a member of an object or something. C++ is great. I love its expressiveness. All right, so what we're going to do is we're going to have each, and we're going to pass callback. And we're simply going to do for each data, or actually let's call it object in objects. And so of course we want to get the type token, so we get the correct list here. And now this is going to be another scary part, but again, remember, we have it. We know exactly what we're getting. We're getting whatever type this object is, so we should never have interference from any other type. So now what we're going to do is we're going to call our callback, but we are going to reinterpret cast. I know, So we're going to reinterpret cast our object to our object star, and we're going to do data.object, because remember, again, it's a void star, so we need to get the actual type back. And again, we're doing it safely because I've specified what types I want, and I'm getting that type token back, which always gives me a unique identifier for every type I pass it. So we shouldn't run into any issues here. There should be no way somebody could accidentally access an invoice when they want customers, etc. And that's pretty much it for the for each. So in fact, I'll do that later. It's not a big deal. But anyway, so at this point, we could do something along the lines of, let's say we do factory.create person. We're going to have Bob, Bobo. Let's have Bob, Frank, and Sue. Is this going to... Did I do something wrong here? This looks right. Undeclared. Oh, right. It's a customer. Sorry, I was thinking of an old example. Okay, there we go. So we create our Bob, Frank, and our Sue. And so if we run this, they clean up nicely. Everything's going according to plan, which is also nice because we aren't actually doing anything with the references it returns. But now let's say that we want to call their say highs. So we'll create a lambda. We're not going to capture anything, but we are going to take a person as first argument. And then we're simply going to do, or an object reference actually. I did it again. Taking a customer. All right, so now we're going to do customer.sayHi. Simple as that. Oops, forgot. We also need to tell it that we're going to be working with customers. There we go. No? No. Oh, that's why I called it. Okay, whatever. It's object.object. Please work. Thank you. All right. So now if we run it, you'll see the say hi's get called for Bob, Frank, and Sue. And it did it safely. So let's say an invoice also has a say hi, except an invoice can't say anything. So we're going to say this is an error. And let's be more descriptive. Invoices shouldn't be able to say hi. Okay. So now let's say in among these, we create a new invoice. And again, invoices don't take any arguments. So we'll just do it like that. So now the question is, will this only call the each for every customer, or are we going to get the invoices say hi in amongst these as well? Now, our each should only work on each customer. So theoretically, we should still get the same results we got last time. But let's see what happens. Indeed, we only have the customers saying hi. The invoices did not. If we wanted to have the invoices say hi, we could do that as well. We could simply do our for each, but we do invoice, 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 and one more time. There we go. And there we go. Now, of course, this is an error. Invoices shouldn't be able to say hi because we told it to say that. So that looks scary, but it's not. But yeah, effectively, we had all of our customers say hi first, and then we had our invoices attempt to say hi second, which they're not very good at, but hey, they tried, so let's give them credit for that. And as you can see, we have also safely destroyed all of our resources correctly. No memory leaks were incurred during the processing of this application. Outstanding. And that is effectively it. What you now have before you is a very useful factory system. I would use this factory if ever you need to create heap allocations where the allocations may exist. I don't want to say heap allocations. Let's say dynamic memory. If you want to create dynamic memory or dynamic objects that exist a little bit more loosely, more like references and things like that, this factory system does a really great job of managing that. You can put it inside of other classes. So for instance, if you're creating a video game and you have a game world and you want that world to be able to generate or spawn objects, you can have your factory system do these things. And it can be completely dynamic. It can be based off of, did the player enter into a certain room, spawn 20 demons. I've been playing Doom 4 a lot lately. So then you can have your factory system do that, or it can spawn a random number of demons or whatever you want. It can do all sorts of crazy stuff. It's completely flexible, into what your needs are as far as managing all sorts of different types of objects. This will work for anything. I mean, I could create a simple integer if I wanted and assign that to 5, and now it will compile, it will create me a 5. That 5 is not going to do me much good, but I can do that. And, of course, I can return it out. So now x equals 5. And my factory is totally going to manage that integer for me. It'll manage any type you want. You can iterate through those types. You can destroy types prematurely if you need to. It's a very, very flexible container and factory-based system. So, guys, use this wherever you want. There's a lot of modability for it. Like, you could actually... let's see, we made it 47. Woohoo! You could actually create a move constructor for it. We could actually do that right now, probably. First, I'm going to need... This is probably going to blow our 50 line count. Ooh, we're actually right on it. Gosh dang, I'm awesome. Technically, that's not under, I guess, though. But you could do something like this, where you do objects equals factory dot objects. Oops, this should actually be stood move. Simple as that. That should compile. And it does. So what that means is that if you need to move a factory up a scope, so for instance, if I go, hey, actually I need a factory 2. Actually, let's do this over here, really illustrate it. If I created a factory 2, I know this is global, ignore that, but we'll call it factory 2. Is it not happy with that? Oh, of course, it's not factory 2. There we go. I could do something along the lines of this. Oops, maybe I can't. Oh, I know why. I need a move constructor. Or a copy assignment. Let's build that real quick, guys. I will be very fast. Let's see if I can remember how to do that. Factory and maybe not as fast. Okay, here we go. Oh my gosh, when I hurry, I can't type. I apologize for that. This actually should be equals. There we go. Okay, that should work. All right, cool. So now, as you can see, we've just taken our factory and we've elevated it a scope. We've taken it out of function main and we just made it a global by assigning it to factory 2. So there's a lot of stuff that you can do with these factories. And, oh, just to illustrate, it still works. So, yeah, you can do all sorts of crazy things with these factories. There's a lot of room for expandability. One of the things I'm trying to work out is using things like my updatables capabilities, where I could actually say, like, a customer is updatable, an invoice is updatable, and to be able to run eaches off of an updatable, and it would work on both the customer and the invoice. That's something I'm still working on. If I figure it out, I did with a previous version, but its implementation was a lot different. But if I figure it out for this particular version, I might do a follow-up video to show you guys how to do that, because that would be super awesome too, because then you can sort of use polymorphism with a factory to be able to run callbacks on objects of like types, or even cooler would be the capabilities types, so they can be heterogeneous but share functions and other methods and stuff like that that happen to have identical signatures, and you'd be able to do callbacks based off of those. There's a lot of things you can do. So, all right, guys, I'm going to leave it here. Explore this, have fun, create cool things. If you create something awesome, tell me about it in comments. And if you have any questions about anything, or you notice I made a mistake somewhere, let me know again in comments. And be nice if you liked the video. I'll see you guys in the next one.